Welcome back to MooMooMath. Today we are finishing up parabolas, which are conic sections. And this is the last lesson in our summer course. We're going to look at vertical parabolas, which means they face up or they face down. And we're going to look at horizontal parabolas, which face left or they face right. So we've already kind of looked at how to do this when x and y squared our vertex is at the origin. Now we're going to throw in h's and k's to kind of move it around a little bit, do some shifting. So in the last lesson we had a chart similar to this, but we've added a little bit more. So we now have the equation where we have an x squared, but it's x minus h quantity squared is equal to 4p and then y minus k. Okay, it's a little bit different. We have this h and k in here. So our focus is going to be at h, k plus p. Our directrix is going to be y equals, remember that's a horizontal line, where k is this value minus p, which is our value you have to count. And then this is has a vertical axis of symmetry, so it's got a vertical line coming down the middle, and it's an up or down facer. Okay, for the y squared, notice the k is with the y, not the x, so be careful when you're writing your focus and your vertex. You got to pick out h and k, okay? So the focus is at h plus p, so you're going to take the h plus the p. They're on the same side, so hopefully that'll help you remember. And then k, and then the directrix is h minus p, and it's got a horizontal axis of symmetry, and it faces right or left. Now, this sounds really complicated on here. I do mine all based on the graph. It makes much more sense to me. So this is a nice little fallback if you need it. Okay, my battery is low. Let's try to get through this. If not, it might have to be in two parts, but that's okay. Okay, first thing you want to do is you want to get the squared term by itself. Find the vertex, solve for p, plot the focus like we did in the last ones, then you want to plot the directrix, and then you just want to get your width, okay? So the first thing we're going to do is look at what we have. Okay, our first one is actually really easy because it's just y squared, okay, and there's no x plus. Okay, let's finish up graphing these parabolas. Okay, the first one we're going to look at is a y squared. Okay, y squared equals 16x. As you can see, there's nothing added to x or y, so our vertex is still at 0, 0. 4p is equal to the coefficient 16, so p is positive 4. Okay, that means if it's a y squared and it's positive, which way is it facing? It's facing to the right. It's a right facer. Okay, so let's plot 0, 0. We're going to count to the right 4. We're going to count to the left 4 and draw in our directrix. And so our focus is at the point 4, 0. Our directrix is the vertical line, which is x equals negative 4. And then we just need to count that width. Remember, our width is whatever we see in the equation, which is 16, so we're going to go up 8 and down 8. And there's the width of our parabola. Okay, now let's jump over to, or let's look at number 2 here. We have x squared equals 2y. The x squared is by itself, so it's in the right form. P is going to equal to, let's see, 4p is equal to 2, so p is equal to only a half. It's the first time we've seen a fractional p. Okay, our vertex is still at 0, 0 because nothing is added to x or y. Our focus then becomes, we have to look at the x squared. It's an up or down, and it's up. It's an up facer because it's a positive p. So the focus is going to be at 0, 1/2, and the directrix is y equals negative 1/2. So it falls right below here, very close to the origin. This one's up a half, and then the focus, we're going to go over 1 to the right, 1 to the left, and so we're only at a half. So it's really tight right there in the middle. It's a little bit hard to see with because it's such a small value. Okay, so now let's look at a couple of these that are shifting. Okay, let's look at number 5. Okay, number 5 is y minus 2 squared equals negative 16x minus 5. Okay, let's focus on p for a minute. What's the coefficient? Well, our coefficient is negative 16. So 4p equals negative 16, so p is negative 4. So there's our p-value. Now it's a y squared formula, and we've learned y squared is either a left or a right facer. And since it's negative, it's going to face to the left, so it's going to look like this. So now we need to know where's our vertex. Now be very careful here, because we need to look at the x coordinate to get the x value. So our x value is 5, and our y value is 2. So 5, 2, there's our vertex. Okay, now we need to plot our p. We need this to face to the left, so we're going to count back 4. So here's 4 backwards. Wait a minute, I plotted that wrong. Sorry. This should be 5, 2 right here. Okay, 5, 2. I went to 7, 2. Okay, so here's our directrix at 1, 2, or our focus, sorry. 1, 2 is our directrix, or is our focus. And then our directrix, we're going to count for the opposite direction. So what does that put us at? 9. So right here is our directrix. Now, don't use this point. That was a mistake. Okay. So here's our directrix, and it's in a vertical line, which is x equals, and that's a positive 9. And then now we need to do the width, okay? Well, we know it's going to be 16, so we're going to go up 8. So from 2, add 8 up, that means that's going to be to 10. 2 minus 8, that's going to bring us down to negative 6. And there is the width of our parabola. Whoops. A little bit tighter here. These smaller graphs are harder to work with. Okay, and the last one over here, number 6. We have an x squared this time. That means it's an up or a down facer. And let's look at our p. Let's see, 4p is equal to 8, so p is a positive 2. So that means it's an up facer, correct? Okay, our vertex. Let's go get our x and y coordinates. Our x coordinate is 6. And our y coordinate is what? Negative 3. 6, negative 3. So 6, negative 3. It's right here. And we know it's facing up. And then we go, and p is 2, so we'll go up 1, 2. So that means that's at 4, 1. I'm sorry, 6, 1. 6, 1. And the directrix is 2 below that, 1, 2. So that puts us at 5, negative 5, right? So that's a horizontal line at y equals negative 5. And that, oops, I don't need that. And then we're going to count our value that's in the equation, 8. So from the focus, we're going to go over 4. So let's see, 1, 2, 3, 4. 1, 2, 3, 4. And there we have the focal width, or the latus rectum. There we go. Okay, so here's our last graph. Now, the last two up here that I skipped over, these are at the origin, and I think you can do them. The only trick on these is make sure you solve for the y squared and the x squared. Well, number 3, the x squared is already solved for. Number 4, you'd have to do a little manipulating, so you'd bring the 12x over and then divide by what? Negative 3, and then you can get your values that you need to graph. Let's look at the last part. Writing equation of a parabola in standard form. Now, we're going to have to do a little completing the square as we did on the circles. So you want to get the squared term and its like term on the left, then move all other terms to the right. We're going to complete the square, and then we're going to factor the left side, simplify the right side, and factor out any greatest common, and then we need to identify the vertex. Okay, so let's see what we're doing here. First thing we're going to do is we are going to get, since the x is squared, we're going to get all the x squared terms on the left and move everything else across to the other side. So that's going to give me a negative 8y and a negative 17. Now I'm going to complete the square. So you're going to half it, half the b term, and square it. So half of 2 is 1, 1 squared is plus 1, but we can't add 1 to one side without adding 1 to the other side. So add 1. Okay, so we added 1 to both sides. Now we're going to factor. So now let's factor. This becomes a perfect square. What we created by adding 1 is a perfect square trinomial, x plus 1 quantity squared, which is the same thing as what x plus 1 times x plus 1. Okay, so you can see that. And then over here we have negative 8 minus 16, negative 8y minus 16. Okay, now we need to factor out the right side. Do we have a greatest common over here? Yes, we do. We have a negative 8. So take a negative 8 out, and that leaves us with y plus 2. And we have an x plus 1 on the left side. Okay, so now we're almost there. We pretty much are done because we've now switched it. We've now got it in standard form. So where's our vertex? Well, our x-coordinate is negative 1. Our y-coordinate is negative 2. 4p is equal to negative 8, so p is equal to negative 2. And then from there, we know how to graph. Okay, let's look at one more of these. Okay, let's look at this y squared one so you can see it. Okay, y squared plus 6y, and then we're going to move the x over and the 9 over, so that's going to give us positive 2 and negative 9. Now let's complete the square. How do you complete the square? You half it, you square it. So half of 6 is 3. 3 squared is 9. So we're going to add 9 to the left, add 9 to the right. Okay, once we do that, we're going to factor the left. And remember, this factors into y plus 3 times y plus 3. But we don't want to write it like that. We want to write it as y plus 3 quantity squared is equal to, well, the 9's cancel, 2x. And we've got it in standard form. So what is our vertex? Well, our x-coordinate, what's added to the x-coordinate? Nothing, so it's 0. What's added to the y-coordinate? Negative 3. And then 4p is equal to the coefficient. So 4p is equal to 2, so p is 1/2. And we just graphed one a minute ago with p of 1/2. It's very small, but you can do it. So there we go, and that's how you switch forms. Now, if you need some more practice on these, you're welcome to complete these and ask me about those. But if you have any questions, let me know.